Hello again, Math 10C. This is the final video in our systems of equations. This is lesson number 6, applications part 2. We've looked at part 1 of applications. We're going to take it a little bit further with some mixture applications and some distance, speed, time problems, which you guys should be awesome at from physics. And then we will be done. And so this is my third attempt at this video, so I'm really hoping that this is going to go well this time around. And so let's just dive right into these mixture applications. So the first example tells us that we have cashew nuts that cost $22 a kilogram, and we're mixing them with Brazil nuts that cost $16 a kilogram. And so the mixture weighs 50 kilograms total and sells for $18 a kilogram. How many kilogram of each type of nut was used in the mixture? And so I like to underline what the question was asking me, because that's going to help me define my variables. So how many kilograms of each type of nut were used in the mixture? Well, I'm going to say I'm going to let my variables be x and y. And so my variables are going to be in kilograms. And so I'm going to say x is going to be kilograms of cashew nuts in the mixture, and y is going to be kilograms of Brazil nuts in the mixture. And so these mixture applications are similar, and I'm going to make a note on the side here, and the fact that most times you write two equations. Your first equation is about the quantity, how much, and the second equation is about a property. So whether this property is cost, whether it's concentration, and other types of things. Those would be sort of our two equations. And so I'm going to go ahead here and I'm going to write you two equations. And the first one is going to be about the quantity, which is how much in this case. So if I add up my x and my y, my kilograms of cashew nuts and my kilograms of Brazil nuts in a mixture, that's to weigh 50 kilograms. And similarly, the second equation I'm going to write is going to be about a property, in this case about the cost. If you're going to pay $22 per kilogram and then you times it by the kilograms of cashew nuts in that mixture, you'll know what percentage of this cost, or percentage, or what part of this mixture costs. And then I can say, if I do the same, $16 times however many kilograms of Brazil nuts are in this mixture, I'll have the dollar amount from the Brazil nuts. And that dollar amount from the cashews and the dollar amount from Brazil nuts need to add up to the total cost of the mixture. And so when I'm looking at this, I'm wondering, is that the total cost of the mixture? In fact, it's not, because it's telling me an average price per kilogram. And so I want to go $18 times 50 kilograms and figure out how many dollars this adds up to. It adds up to $900. And so make sure sort of your units are matching. And when I say that, I mean here I had kilograms plus kilograms equals kilograms, dollars plus dollars. I don't want to use dollars per kilogram, I want dollars. So that's why I did the multiplication there. Okay, you have your choice when it comes to how you want to solve this system. Once you set it up, that's the hardest part, is setting it up, and then you just pick a strategy and go with it. And so elimination is my personal favorite, so that's what I'm going to do here, because I can see it's pretty easy to multiply this top equation either by 22 to eliminate x or by 16 to eliminate y. And so I'm going to multiply by 22. Everything gets multiplied by 22, so I have 22 x plus 22y equals 22 times 50 equals 1100, or 1100. And I'm going to rewrite my second equation below it so that it's all lined up nice. Numbers lined up, y's lined up, equal signs, and that is equal to 900. And so in elimination, you have to add or subtract these equations so that one variable is eliminated. And so if I subtract I can see that 22x minus 22x would go to 0, and x would be eliminated. So 22y minus 16y is what's left. That makes 6y. 6y equal to 1100 minus 900, that would be 200. If 6y is equal to 200, if I divide by 6 on both sides, 200 divided by 6, 33.33, that's repeating, or that would be a third, 33 1/3 kilograms. Okay, I was solving for y, I was solving for kilograms. I can't even write here what it is about, but I'm going to write a sentence later. Okay, I have my y. I need to choose an equation, go back and solve for x. Now this one to me looks the easiest one to sub in a y to. So I'm going to take that over here. X plus y equals 50. That's my kilograms. Kilograms plus kilograms. Supposed to total 50 kilograms. I need to find out how many kilograms I'm missing from 50. If I have 33 1/3 for y, so I'm going to take away. And so when I'm typing this on my calculator, I'm just going to show you what I have. Right now I have 33.3 repeating, and when I would go to subtract this, I go 50 minus, I get second, the negative sign, which is answer, second answer, 16.6 repeating. And I'll show you how I would get my fraction too. I want to take away the whole number, so I'm just going to take away 16. And then I want to know what portion or what fraction this corresponds to. And I'm going to math fraction that. 2/3, 16 2/3. That was in kilograms. And so I'm going to state my solution to the problem. The question was, how many kilograms of each type of nut were used in the mixture? Well, x, 16 2/3 kilograms of cashews, and 33, or y, 33 1/3 kilograms of Brazil nuts were used in the mixture. Okay, so 16 2/3 kilograms of cashews, 33 1/3 kilograms. It would be totally acceptable as well to leave these in decimals, but just looks nicer if we have that repeating decimal. We can make a nice fraction. Okay, let's go take a look at the second problem here. Earl has to make 180 milliliters of 60% hydrochloric acid solution. So he doesn't have a bottle of 60% hydrochloric acid solution. He needs to make it, and he needs to make it from some volume of a weaker solution at 45% HCl, and some volume of 70% HCl, so a stronger solution. And so how many milliliters of each solution should he mix to make the 60%? Underlining what the question asks to help me write my equations. Milliliters of each solution. So when I go to write my variables x and y, I'm going to say milliliters of, and then I'm going to clarify which is which. Milliliters of x is going to be the 45% HCl solution. And y, how many milliliters of the 70% HCl solution? And so if I go back to that general format, there should be a quantity somewhere in this problem, and there should be a property. And so the quantity is 180 milliliters. And so if you're going to add up milliliters, or pour in some milliliters of the 45% and some milliliters of the 70%, total you can only have 180 milliliters. So this would be the quantity, and if you want, you can write milliliters beside it so you know what you were saying. Something plus, so some volume of the weak and some volume of the strong acid solution should equal 180 milliliters total. And then you have something about the property. And so in this case, 45% and 60% are your solutions. And so I'm just going to clarify that 45% over here, if we want the decimal, I divide by 100, that's 0.45. And 70%, dividing by 100 to get the decimal, would be 0.70. And so the concentration of the 45% solution times the volume, or X, of the 45% solution, now I have a milliliter, or a percentage there, plus 0.70 times, so 70% of the 70% solution, however many volumes you have. And you're trying to make a 60% solution where the solution's volume is 180 milliliters. So this concentration times how many milliliters of the acid solution, this is really finding how many milliliters of pure, almost HCl, if you want to think of that, you would have, plus 0.7 times Y, how many, or what percentage of that pure HCl, and then 60% of this solution should be pure HCl. And so similar to the cashew type problem, I did have to multiply. There was kind of that hidden step where up here we did the 50 times 18. Down here, 0.6 times 180. So 0.6 times 180 is actually 108. Okay, so I can choose either method. I can graph, I can do elimination, I can do substitution. In this case, I'm going to show you the substitution. So I'm just going to first rewrite part of this. So I'm going to say x plus y is 180. I get to choose x or y. I'm going to go over here and say, well, then that means x equals 180 minus y. Taking away the y to the right side, x equals 180 minus y. And so, again, following what I've done in previous lessons, there's a box around that. That corresponds to x. You have to find x, and you have to replace it. And so I'm going to take this second equation that says 0.45 times x, replace x with 180 minus y, plus 0.70 times y. That's equal to 108. And so now it's a matter of solving this multi-step equation rather than any other processes. Because I've done sort of my substitution already, I have to just do some algebra here. And so I'm going to share that 0.45. 0.45 times 180 is 81. 81 minus 0.45 times y plus 0.70 times y equals 108. I can put the negative 0.45 and the positive 0.7 together. Oops, not negative 45. Negative 0.45 plus 0.7. 0.25. So I have 0.25y, there's an 81 in front of that, equals to 108. Gonna subtract the 81 to try and get y alone. So I'm gonna go 81 minus 81, that goes to 0. What's left? 0.25y. 108 minus 81 is 27. And so lastly, 27 divided by 0.25 to get what is 1y. 27 divided by 0.25 is 108. And once you have your y value, go back and find the x value. X is 180 minus y, which means 180 minus 108. And 180 minus 108 is 72. So I have x is 72, Y is 108. I'm going to clarify what that means. How many milliliters of each solution? Let's go up here. I'm going to write my answer. I'm going to say I have 72, or that was X, 72 milliliters of the 45% solution. And 108, that was the Y value, 108 milliliters of the 70% solution are mixed. Okay, so now I have overall a solution that would be of a quantity of 180 because the volumes add up to 180, and we've shown with the math here, we could go back and prove it too, that there would be in fact 60% of that 180 milliliters being pure HCl. Okay, let's go to a distance, speed, time problem. And we have two problems here. Distance, speed, time problems actually carry through 20-1 quite nicely because we start using these again there. So this is good practice for us. And so I want you to, when you start distance, speed, time problems, draw a table. Draw me a distance, speed, time table, which says, here is my distance. What was the speed? What was the time? And this helps me sort of divide up or try to write what I need to know and what I need to solve for. And so a student is driving 1,245 kilometers from Edmonton to Vancouver in 16.5 hours. This included a 1-hour stop in Golden and a 30-minute stop in Kamloops. She averaged 100 kilometers on the divided highways and 75 kilometers an hour on the non-divided mountainous roads. How much time did she spend on the divided highways? Okay, I'm going to divide this up into two sort of cases. First, divided highways, divided highway, and then she had mountain roads. Okay, and so she was going, this is where I fill in the boxes, she was going 100 kilometers an hour on the mountain, or on the divided highway, and only 75 kilometers an hour on the mountain road. And so next I want to say, okay, well, how long did this take? And I have not enough information to say how long she spent on each road, but I do know she took 16.5 hours to make the trip. So I can say driving time, 16.5 hours to make the trip, but she stopped for a total of 1.5 hours. So 16.5 hours minus 1.5 hours. She did this trip in about 15 hours. Okay, so I'm going to say, I don't know what time she spent on the divided highway, don't know what time she spent on the mountain roads, but I do know that those two times together have to add up to 15 hours. Okay, and so if I'm going to write a system of equations, here's one equation in terms of x and y. I need two. And so this is where distance comes in, and this is where it helps to have that distance, speed, time triangle, or that distance, speed, time formula that says the distance is the speed times the time. The speed times the time. 100 times x on the divided highway, or the distance, again, speed times time, 75 times y, 75 times y on the mountain roads. And so now I have another column with x and y that I'm going to use to write how far she traveled. Well, she traveled 100x kilometers on the divided highway and 75y kilometers on the mountain roads, and total she had to drive 1,245 kilometers. Okay, you get your choice in how you want to solve this. I've shown you elimination, I've shown you substitution. I think we're going to try and do this one by graphing so that I can show you that method as well. So let's work towards graphing this. And so I kind of want to say here, let's graph two equations. The first one has to be y equals, I'm going to call it y1. And so I can almost label this y1. This is what I'm aiming to isolate. I can do that by subtracting x, so that y1 I'm going to graph 15 minus x. And this one's going to be harder. y2, if I label that y as y2 and I work towards isolating it, first I have to subtract the 100x to get 75y alone. And then I have to divide by 75 to get this as just y equals. And so I'm going to have to do a little bit of math here. y2 in my calculator would look like 1,245 divided by 75, which is 16.6 minus 100 divided by 75. 1.3, repeating if that's a fraction, that'd be more specific, minus 4/3 x. And so I've got two equations. I took this system, manipulated it for y to get, and I labeled that y1 because that's going to correspond with how I enter it in my calculator. This one I've labeled the y value y2, manipulated it for solve for y value, and now we're going to graph this. And so on my y equals, clear any graphs you have, and then we're going to graph in y1 15 minus x, and y2 16.6 minus 4/3 x. Graph. Can I see the intersection? Yes, I can. And so this is on a window I had from a previous question. Let's just look at that window quick. This must have been from maybe lesson number 5. It says 0 to 25, 1, 0 to 20, 1. Okay, but what's important is that I can see that intersection. Let's figure out what that is. Second calc, intersect, enter. They intersect at x equals 4.8, y equals 10.2. And so let's go back and figure out which question, or what was the question. How much time did she spend on divided highways? Divided highways, time was x. So really I just have to say, what is x? 4.8. What is x in? Well, speed was in kilometers an hour. Distance was in kilometers, which means time must be in hours. So I'm going to say she spent 4.8 hours on the divided highways. And I didn't even want to know really how much time she spent on the mountain roads, but I can answer that question as well. Say 10.2 hours on the mountain roads. Okay. Last question here about a boat cruise. Again, I want you just to copy the same table, distance, speed, time table. This is your starting for all of these problems. Here's distance, here's speed, here's time. And so I'm going to have two sort of portions to this problem, while it's highways or mountain roads. In this case, we're talking about a cruise boat. So a small cruise boat took 3 hours to travel 36 kilometers down a river with the current. On the return trip, it took 4 hours against the current. Find the speed of the current and the speed of the boat. Okay, let's split this trip in half. First time they went down the river, they were with the current. This speedboat was with the current. And when they returned, they were against the current. So I'm going to have a portion of this trip with the current, a portion of this trip down the current. And so the whole point of moving with the current or without against the current is that if we say that x is the speed of the current, and y is the speed of the boat, and we should maybe add to that in still water. So we're saying just the boat on its own. When we go with the current, we would say we have the speed of the boat, but the current helps you. You get a faster speed, so y plus x. And when you're against the current slows you down. You would have your speed of your boat, you take away the current. And so when you were with the current, the small cruise boat took 3 hours, and against the current, it took 4 hours. Okay, and so I'm going back up to that triangle to try and fill in the third part of this. It says distance equals to speed times time. Distance equals to speed times time, or 3 times y plus x. And speed times time down here would be 4 times y minus x. And so now that I have this here, I want to solve sort of 2 equations. And I'm going to separate these equations into the trip there and the trip back. Because if I write speeds, I don't know an average speed or anything. So I don't want to write an equation using the speeds. In fact, I just really want to use these 2 boxes, the distance boxes, because I also had an information here that I haven't used yet, and it said the small boat cruise was 36 kilometers each way, which means this was 36 and this was also 36. So I'm going to write 2 equations there and say 3 times y plus x, that's equal to 36. And 4 times y minus x, that's also equal to 36. And now it's a matter of sort of expanding this system. I'm going to share and care first so we can, or share that 3 with the expression and share the 4 so that we can look at this system without brackets. 3 times y plus 3 times x equals 36. 4 times y minus 4 times x equals 36. And so if I want to set up this system and I want to solve it, I need to multiply one by the other, or try to get them to the same. I can choose with elimination to multiply them both and get them both to 12, because the common factor between 3 and 4 would be 12. And so in fact, that's what I'm going to do. Because elimination is one of my favorites, I'm going to say, let's make all of these coefficients 12. That means I have to times that by 4. And let's make all of these coefficients 12. Or not coefficients, but the leading coefficient, the y coefficient 12, multiplied by 3. And so when I multiply that, I go 12, 3 times 4, 12y plus 12x is 36 times 12. 432. Not 36 times 12. 36 times 4. 36 times 4, 144. And then here, 4 times 3, 12y minus 12x equals 36 times 3. It's 108. Okay, so 12y plus 12x is 144. 12y minus 12x is 108. And so something beautiful happens here. Or I shouldn't say that, but this is really cool that I can subtract and eliminate y, or I have the choice. I have the choice to add and eliminate x. It doesn't matter which one you do. I'm going to add these because very rarely does that happen, that you get your coefficients being the same number but maybe different or opposite signs. And so you might be under the impression, well, if you add, you're going to eliminate both x and y. That's not true. Or if you even, maybe you think, oh, if you had subtracted here, you would eliminate y and you'd eliminate x. But you'd have to remember, if you subtracted 12 minus a negative, that would still be like a double negative, which would be like adding. So 12 plus 12, 24y. Positive 12 plus negative 12 is gone. It's eliminated. X is 144 plus 108, 252. I'm going to divide by 24. 252 divide by 24 to get my solution for y. Y equals 10.5. And then I'm going to go back and solve for x, any one I want. Which one would be easy? Let's go back to an original that says 3 times y plus x equals 36. 3 times y plus x equals 36. And now I know what y is. 3 times 10.5 plus x equals 36. I'm working to solve for x. I want to divide by this 3. I could also like distribute that and then do all the division, but this looks easier. 3 divided by 3 is 1, so I really only have 10.5 plus x left over there. 36 divided by 3 is 12. 10.5 plus something equals 12. Minus 10.5 from each side, I can see x equals 1.5. And so I have to go back and find the solution. It said find the speed of the current and the speed of the boat. So I'm going to go and state my answer and say the speed of the current is 1.5 traveling kilometers an hour, 1.5 kilometers per hour. And the speed of the boat, what did I label the boat? Yeah, speed of the boat was y, so I find y. Speed of the boat was, or is, 10.5 kilometers per hour. Okay, so a lot of applications, difficult applications in this lesson. Take some time to go back and go through some of them if you need. Otherwise, head on to Google Classroom, try your assignment, and there'll be an exit slip posted.